Today we're going to start our lesson by talking through some vocab, and so the first vocabulary word that we're going to talk about is prime numbers. So I'm just going to write that on the outside here. The next thing that we're going to talk about are composite numbers. We're going to talk about factors and multiples. So we're just going to start out with some vocab. I'm going to start up here at the top with prime numbers. If you open this little foldable up, in the middle I'm going to rewrite the word that we're talking about, prime numbers, or prime number. The definition of a prime number is a whole number greater than 1 with exactly 2 factors. Those factors are 1 and itself. So a prime number is a whole number greater than 1, whole number bigger than 1, 2 factors, 1 in itself. So some examples would be, and when I'm talking about factors, I'm talking about numbers that multiply by each other to get this. So an example of a prime number would be 2. 2 is actually the only even prime number because it's the only whole number bigger than 1 with 2 factors, 1 and 2. 1 times 2 is 2. Those are the only 2 numbers I can multiply together, whole numbers I can multiply together to get the whole number 2. Another example of a prime number would be 3. 3 is a whole number, it's bigger than 1, and it has 2 factors. It has 2 numbers that multiply together to give us 3. 3 and 1, 1 in itself. Some other examples would be 13 and 73. Again, 13 and 73 are both whole numbers. They're both greater than 1, and they have 2 factors, 1 in itself. 1 times 13 is 13. No other numbers can multiply to give us 13. And 1 and 73. No other numbers can multiply together to give us 73. Some non-examples of prime numbers. 1 is a non-example because it is not bigger than 1 and it only has 1 factor. 1 times 1, that factor is only 1. 0 is a non-example because it is not bigger than 1. So automatically, by definition, 0 is not a prime number, or is not a prime number. We have other numbers like 4. 4 is an even number. You can do 1 times 4, or you can do 2 times 2. Another example would be, non-example of a prime number would be 66. You can do 1 times 66, but because it's even, we know that 2 goes into it. We can do 2 times 33. There are more factors like 3 times 22, and we might be able to 6 times 11. Are all factors that multiply together to give us 66. And because it has more than 2 factors, it's a non-example. It's not a prime number. Another non-example would be 100. There are lots of ways to get to 100. 1 times 100, 2 times 50, 4 times 25, 5 times 20, and we could keep going 10 times 10. So this has a whole list of factors, definitely more than 2 factors. So it's a non-example. It is not a prime number. And so the characteristics are that there are only 2 factors. It's greater than 1, and they are whole numbers. Prime numbers are whole numbers. So first we talked through prime numbers. Now, if a whole number isn't prime, it's likely that it's composite. And so the second thing that we're going to talk about today is composite numbers. Composite numbers are, or a composite number is a whole number greater than 1 with more than 2 factors. So, for example, we talked about 4 just a little bit ago. 4 has factors of 1 and 4. 1 times 4 is 4. It also has a factor of 2 because 2 times 2 is 4. So 4 has 3 factors, 1, 2, and 4, which is more than 2. And so it is an example of a composite number. Another example could be 55. We know that we can do 1 times 55 to get 55, or we could do 5 times 11 to get 55. Another example would be 63. 63, we know 1 times 63 always works, 1 times itself, but we also could do 9 times 7, or we could do 3 times 21. Because it has more than 2 factors, it's a composite number. So some non-examples. Again, we've got another non-example. 0 is a non-example again. 0 is a whole number, but it's not greater than 1, so it automatically is ruled out. 1 is a non-example. It is a whole number, but it is not greater than 1. It's equal to 1. It has 1 factor, so it is not composite. It definitely doesn't have more than 2 factors. Some other non-examples, the number 7. 7 is prime. It only has factors of 1 in itself. 1 times 7, nothing else. Another non-example would be 19. 1 and 19 are the only factors of 19 that we can multiply together to give us 19. So some characteristics of a composite number is 3 or more factors. It has to be greater than 1, and it has to be a whole number. So if we're going to be talking about factors this unit and talking about factors when we're talking about prime and composite, it's really important then that we define what a factor is. And so on this next one, we're going to write in factor. And a factor is an integer that divides evenly into another. Or when we have 2 factors, they're 2 numbers that multiply together to give us. So some factors of 12. Let's talk about factors of 12. We know that we could do 1 times 12, so 12 could be on our list. We could do 2 times 6, so 2 and 6 could be on our list. We could also do 3 times 4, so 3 and 4 can be on our list. So factors of 12 are 1, 2, 3, 4, 6, and 12. They divide evenly into 12. We've also got the number 36. If we list the factors of 36, we know that 1 times 36 would give us 36. We know that 2 times 18 would give us 36. 3 times 12 gives us 36. 4 times 9 gives us 36. And 6 times 6 gives us 36. All of these numbers divide evenly into 36. They go in evenly, so they are factors of 36. So some non-examples would be, if we're talking about the factors of 12, would be 5 or 7. If we're talking about 36, some non-examples would be 5 or 7 or 8. Characteristics of factors. 2 factors equal a product. The last vocab word that we're going to talk about today is multiples. Or a multiple, and a multiple is the product that number and another whole number. Some examples of multiples. If we were talking about the multiples of 12, 12 times another whole number would be 1. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12, 24, and 36 are all multiples of 12. We multiply to get multiples. We could talk about multiples of 4. Multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. The list can keep going for multiples. We could go on and on. It's infinite. 4, 8, 12, and 16 are all multiples of 4 because you multiply by another whole number to get these products. So some non-examples, multiples of 12. Some non-examples would be 1, 2, 3, 20. We can't multiply 12 by any whole number to get 1, 2, 3, or 20. So the characteristics, it sounds similar to multiply. Multiple, multiply. Because when you multiply, you get multiples. So it sounds similar to multiply because when you multiply, you get multiples. The last thing that I want you to add to this note sheet really quickly is between prime and composite. I just want you to write 0 and 1 are neither prime or composite. Once you do that, you can wrap up your vocab for today. We've got prime numbers, composite numbers, factors, and multiples.